Kubernetes looks clean in a demo, right until your app needs a deployment, service, ingress, config map, secret, auto-scaling, and 3 environment-specific changes. That is where Helm charts show up. Beginners usually learn one install command and stop there, but professional teams use Helm as a repeatable packaging and release workflow. In this video, I will take you from the first mental model to the production details that actually matter. First, I will explain what Helm is and what a chart really contains. Then we will open the chart and walk through each important file like Chart.yaml, values.yaml, templates, helpers, and dependencies. After that, I will show how values flow into templates, how install, upgrade, and rollback work, and what separates a chart that only works on a laptop from one a team can trust in production. I will also use simple examples, so every moving part means something, not just names on the screen. Helm is often called the package manager for Kubernetes. That description is useful but incomplete. A Helm chart is really a reusable bundle of Kubernetes resource templates, configuration values, and release metadata. If raw YAML is a pile of individual files, a chart is the structured application package that turns those files into one installable unit. And when you install that chart, Helm creates a release, which is a named deployed instance of the chart. That is why the same chart can deploy dev, staging, and production with different values. Now open the chart. Chart.yaml describes the chart itself. Name, version, description, type, dependencies, and app version. The chart version tracks the package. App version usually tracks the application inside it. Those two are not the same thing. Values.yaml is the default configuration layer. This is where image tags, replica counts, resource requests, ingress hosts, feature flags, and service ports often live. Templates is where Kubernetes manifests become dynamic blueprints. You will see placeholders like .values, .image, .tag, .release, .name, and helper functions. Inside templates, .helpers.tpl usually stores reusable naming logic, labels, and snippets, so the chart does not repeat itself everywhere. Charts holds dependent charts when you vendor or package dependencies, and files like .helminure or notes.txt are smaller but still useful. One controls packaging noise and the other can print post-install guidance. Here is the core render model. Helm takes templates, values, and release information, then renders plain Kubernetes YAML. That means the cluster never reads Helm's syntax. Kubernetes only sees the final manifests after Helm fills the placeholders. Values can come from multiple places. You can keep defaults in values, .yaml, override them with values, prod.yaml, and override again on the CLI with set, although large teams usually prefer files or Git managed values over long command lines. Templates can also use conditions, loops, pipelines, defaults, includes, and functions from Sprig or Helm. That power is useful, but too much logic can make a chart hard to reason about. A professional habit is to run Helm lint and Helm template before install or upgrade so you can inspect the rendered output before the cluster sees it. Now the operator workflow. Helm install gives a release name and deploys the chart with a chosen values set. Helm upgrade changes an existing release while preserving its history. Helm rollback moves that release back to an earlier revision if a bad change ships. In practice, teams often keep separate values files for dev, staging, and production, while the chart structure stays mostly the same. That is one of Helm's biggest wins. You are not copying whole manifest folders for every environment. You are reusing one packaged application shape with controlled overrides. Now the professional layer. A good chart keeps templating readable, keeps values well named, and avoids hiding business logic inside template tricks. Versioning matters. If the chart changes, bump the chart version. If the application version changes, update app version. Teams need that difference for packaging, rollout, and rollback clarity. Dependencies matter too. A parent chart can include subcharts, but if everything becomes one giant nested chart, maintenance gets harder. Reuse should help, not bury meaning. Secrets need care. Do not treat plain values files as a safe place for raw production secrets. Teams usually combine Helm with external secret tools, sealed secrets, SOPs, or platform-native secret workflows. And one more warning. Helm does not replace review, testing, or observability. A bad chart can automate bad deployment habits very efficiently. So here's the simple mental model. Helm is the tool. A chart is the package. Values.yaml is the configuration layer. Templates is the blueprint layer. A release is one installed instance with history. If you understand those 5 ideas, most Helm documentation becomes much easier to read. Start by reading one small chart, rendering it locally, changing a few values, and comparing the output. That is the fastest path from beginner confusion to professional confidence. If you want, next I can break down a real Helm chart line by line and show how to package, lint, and ship it safely.